Hello everyone, welcome to our another video in the series on mastering data structures and algorithms. The topic of this video is when the deletion needs to be performed in a linked list based on a key value. Key means we are given a certain data item value. We have to search through the linked list and find out the exact position from which this deletion needs to be performed where the key value exists. A key may or may not exist into the linked list. So let's see. I'm Dr. Prashant K. Gupta. There's a link to my website. It contains a lots of good downloadable materials in the form of PPTs, links to the explanation videos, C programs for these practicals, as well as more information about me on my international visits, my publications, my patents, etc. My passion is research and teaching. So let's begin. This is case number 3, where the deletion needs to be performed from the linked list. And this deletion is based on a data item value. We are given the value of a data item provided by a user, and we have to search through the linked list and delete that data item, or rather delete the particular node on which the data item value exists. Now the list can be unsorted or sorted. So let's see the case number 3a, where the deletion needs to be performed and the list is unsorted. We have called our procedure delete data on the basis of data actually, or the key, and the list is unsorted. We are making use of two pointers, previous and temp, and as done in the previous video, temp holds the address of the node that needs to be deleted, which will be containing the data, and previous will be node that will be existing just before the node with the address temp. So we're going to check if the start value is null. So we're going to print that list is empty, and we're going to exit out of the program. In case if data value is found to exist in the first node, so then data value will be equal to the start info, and then we are going to call the delete beginning procedure, which we have already discussed. If none of these two cases are true, so the control jumps to the else part, where we initialize the value of previous with the start value, that is address of the first node, and temp's value will be assigned to the start link, that is the address of the node that is second into the linked list, because the data value for the first node we have already checked over here. Now in the while loop we will be checking while the temp's information is not equal to the data, that is till the time we don't find the data value, and temp's link is not equal to null till the time we don't reach the last node, then we are going to set the value of previous equal to the temp, and temp will be incrementing to point to the next node using temp equals to temp link. When we reach a particular node, so either of these two conditions false, either we have found the data value that needs to be deleted, or through this condition, or the scenario is that we have reached the last node. So by performing this check, if temp info is not equal to the data, which means the data value that needs to be deleted is not even found in the last node, we'll print that data value is not found. Else we simply set the value of previous link equals to the temp link, and we're going to free the memory allocated to the temp. So as we discussed in the last video, I'm going to reiterate over here by using this condition over here. That is, instead of using temp not equal to null and simply using temp link is not equal to null, we are saving one iteration of this while loop. We'll see this later on. Let's see an example. Let's say the data value that needs to be deleted is 3, and we are given this linked list. So clearly we can see that start is not null, as well as data is not equal to the start info. Therefore, these two statements are not executed. Control jumps to the else part. So the result of executing these two statements inside the else part, you can see both the values of previous as well as the temp are set. Previous points to the first node, and the value of temp is set to point to the second node in the linked list. Now we check if temp's info is not equal to the data and temp's link is not equal to none. Now temp's info is 22, which is not equal to data. So this not equal to condition is true, and temp's link is not equal to the null. This not equal to condition is also true. So both these conditions the while loop are true. This will cause the previous value to become temp. So now you can see now previous starts pointing to the second node instead of the first. which it was pointing earlier over here. And temp's value is incremented to point to the next node. The temp's value becomes temp's link. That is, it points to the third node. So now again we check if temp's info is not equal to the data and temp's link is not equal to the null. Over here, the second condition is true. However, first condition is false because temp's info is equal to the data. So this being a logical AND between the two conditions, it causes the exiting of the while loop. So now we come into the while loop and we check if temps info is not equal to the data. Now please be cautious of this condition. This is not equal to the data. But in fact, temps info is equal to the data. So therefore, the control jumps to the else part and sets the value of previous link equals to the temps link. Now previous link points to the second node into the linked list. And as soon as we do this condition, so a link is between that existed between these two nodes is broken. And now previous link starts pointing to the temps link, that is the fourth node into the linked list. So this direct link is established. And then we free the memory allocated to the temp. Now, as I was earlier talking, just returning to the fact again, by use of this condition that temp's link is not equal to null, it is highly possible that the data value that we want to delete is 55 that is existing in the last node. So in that scenario, temp will be pointing over here, previous will be pointing over here. And by checking of this condition, the temp's link is not equal to null. So this condition is going to become false and our program is going to exit out of this while loop. So these two conditions are not going to get executed. So you can essentially see that I have saved one iteration of my while loop. Now over here we'll come to the if part and we'll check if temps info is not equal to the data, which is actually not true because temps info is equal to the data that we want to delete over here. So this statement will not be executed and previous link will be set equals to temps link. Now you can clearly see over here the temps link is null over here. So as soon as we set the value of previous link equals to the temp link, so previous link now becomes null. Therefore, this node will simply be deleted from the memory. This link will be broken. And then after execution of the free temp, this node will cease to exist into the linked list. So this is a very inclusive program. And this is a classical example for all our viewers to understand and everyone to have a look at how you, by using the temp link not equal to null, instead of using temps not equal to null, we are saving one iteration of the while loop. Now this is the conversion to the C program. This is the structure declaration. We have our initialization of the pointers and this is an integer data type declaration. Now we are prompting the user to provide the data value to input into the linked list and we are going for checking of these two conditions over here. If start is null or data equals to start info, so we are taking the appropriate execution steps into the program. Now the program jumps to the else part where we initialize the previous and the temp value and we check inside the value while loop whether the temps info is not equal to data and temps link is not equal to null. Till then, previous equals to temp and temps equals to temp link. The incrementations and setting of the values of the pointers are taking place over here. When we exit out of the while loop, we'll check if temps info is not equal to data. We'll print that data has not been found. Else, we print. Else we set the value of previous link equals to temps link and we free the temp value, memory allocated to the temp. Thank you all for watching this video and don't forget to subscribe to our channel for more and more good videos that will be coming up soon. Thank you.